No, thanks for the invitation, Stuart. I really appreciate it. I think probably this is my first presentation to the Chartered Association of Building Engineers. So, yeah. So, yeah, as Stuart says, I head up the Fire and Structures team at the Scottish Government Building Standards Division. So my background is in building standards itself. I worked with local authority building standards for about 18 years. And I moved to the Scottish Government in 2001. And I've been there ever since, really. So I did have certification at one point under my umbrella as well, but obviously post Grenfell it all started to get a little bit hectic. So I managed to dispose of certification to elsewhere in the division. So that's really my background. It's kind of career anchored building standards. I did decide to go back and do a fire engineer late in my career as well for my sins. So basically chartered surveyor, RICS surveyor, and a BEng in fire risk engineering. So what I'm going to cover, if my slide works, yes. Just a brief history to the standards, guidance and concept of large-scale fire testing, to this large-scale test of BS 8414 and 135 assessments. I'm going to cover, obviously, UK government large-scale fire testing. Now, some of you have probably seen some of this before, but I'm happy to take sort of questions at the end, and Stuart will, Stuart, post them in the group chat, and that'll be absolutely fantastic, and we'll pick them up at the end. The key changes to the building regulations and guidance that came in post Grenfell, again, I'll just touch on them because most of you should be fairly familiar with them, and then a brief overview, the current and ongoing work that's going on in the world of fire safety, particularly with the Scottish Government. So that's what I'll be covering. So I think I just wanted to post this little slide beforehand. It's, if you visualize a completely non-combustible building, so that's non-combustible floors, walls, you can indeed get fire flanking, leapfrogging from one flat to the other in a completely non-combustible building because of the window arrangements. Obviously, you get the downward heat radiation. You can ignore the firefighters because the 2 floors below have already burnt out. But that is a fundamental assumption in the BR 135 performance criteria, is that basically by the time that the fire gets to the 3rd flat, it is deemed to be sort of 15 minutes post flashover coming out of that original dwelling of origin. So it has to be under the right conditions, ventilation conditions, windows open, etc. And I have to say, fire rarely spreads beyond the dwelling of origin, but I'll come on to that a little bit later. But that is a completely non-combustible building, and the assumption really in BR 135 is by the time it gets to that 3rd flat, it's deemed to be a failure within sort of 15 minutes of the start time. So that's within 15 minutes of the time that the fire broke out of that window post flashover from a small compartment fire. That's the concept anyway. But that's in a non-combustible building. So that's, if you like, the benchmark that we're assessing it against. In the good old days, we used to have the post-war building studies, and we never ever dealt with the window-to-window alignment and blocks of flats as regulators for obvious reasons, aesthetics, etc. But we did have spandrel panels in the post-war building studies up to about 900 millimeters between windows, if you like, from the top of one window to the sill of the next window. That 900 mil was done a reasonable job, but fire can easily bypass that as well, that 900 mil, because of the flame extension. But as I say, I'll come on to this in a wee bit more detail. So the first edition was published in 1988. There was no standard full-scale, large-scale test available at that time. So this was design guidance only, targeted at local authority building, basically architects, designers, developers at that time. So it wasn't cited in the technical handbooks at that time. And it was really just to alert them to the risks, the fire risks posed by the thermal insulation getting put on the outside of buildings, really in the 90s, 2000s. So there was a bit of a proliferation in external wall cladding systems, thermal insulating material on the outside of them. And the test work behind the first edition was based on a large-scale single-faced wall test. But we had the Knowsley Heights Liverpool fire, so this single wall all of a sudden became two walls with a side wing. And why was that significant? Basically, it generates sufficient radiant heat, if you like, back into the fire. Also, the fire tends to create its own vortex, which accelerates the fire growth exponentially up the face of the building, and it generates more heat as well. So you've got this vortex plus the radiant heat back into the fire. So it was decided that the return wing should be included in the test, and most of you may be aware, Fire Note 9 was then born to a certain extent, which was the predecessor to BS 8414, and it included this wing wall, 1.5 meters wing wall, into the test methodology back in July 1999. There was no fatalities in that particular incident, but it did shoot up the building rapidly. So we then had in June 1999 the Irvine fire, and again similar scenario where in the rumour fire origin it was flashover. Can't remember if the window was open or not at the time, or it broke out the window. But to cut a long story short, it very quickly spread up the face of the building into about 7 living rooms were on fire by the time the fire service arrived, which was literally about 6 minutes after the first call to the fire service. So they were there quite quickly, but there was about 7 living rooms on fire. So that is obviously what we do not want, because you could argue then that's the stay put strategy being completely compromised. So that was in June 99. Brian Donoghue, MP, the MP for North Ayrshire, was instrumental in getting a UK parliamentary inquiry by the Subcommittee of Environment and Transport and Regional Affairs back in the early 2000s, and that looked into this quite significantly in terms of this potential for vertical spread. And as you can see in that picture on your right-hand side, not a lot of combustibles in that particular building, but the infill panels below the windows were obviously combustible. There was issues with lack of compartmentation at each of those floor levels. But as I said to you before, the flame extension would just sort of bypass that anyway. And so we've seen a lot of the buildings like this in Scotland, obviously, but it just shows you the potential that could happen with combustible infill panels, but below the windows. So one of the striking, I suppose, quotes from that committee report was that we do not believe that it should take a serious fire, which many people are killed, before all reasonable steps are taken towards minimising the risks. And that was published in the 14th of December 99. The reason that I've highlighted that particular date is because on exactly the same date, this Fifth Amendment was laid in the Scottish Parliament, and that came into force in April 2000 under the 99 regulations that you can see there. So it basically, Class O cladding and non-combustible insulation was introduced in external wall cavities, to all high-rise buildings greater than 18 metres. So basically, non-combustible insulation in all high-rise buildings, and the Class O cladding was introduced. The Class O, as we know, has come under significant scrutiny as part of the Grenfell inquiry. And I'll talk about Class O in a wee moment. So just quickly moving on to 2002. This was the Sixth Amendment. And basically, this was the first time that was cited Fire Note 9 in the building regulations and the technical standards at that time. And it was there as an alternative to the table that was quite prescriptive table. So we were really trying to promote large-scale testing of the system back in 1999. And also on the same Sixth Amendment, fire resisting cavity barriers, if you like, were introduced, 30 minutes fire resisting to the rain screen cladding at every upper floor level as well at that same time. So I on this second edition of the BR 135, and it basically just introduced the masonry standard, if you like. BS 8414 was the masonry standard, and that was replacing that building that BRE note, fire note 9 that I spoke about just a moment ago. So this was the first time really that 8414 was, if you like, cited in the technical standards. Which was the 1st of May 2005 under the new system. So at that time, it was supposed to be a technically level transposition with the old technical standards and the new technical standards, but we did take the opportunity to try and promote this large-scale test again. So we kind of tightened up on things from the Class O to the non-combustibility requirement. So that's been in place for quite a long time. So basically, the external wall cladding system, so that's your outer cladding and your insulation should, and domestic buildings over 18 metres should be non-combustible or meet this performance criteria in BR 135 and tested to the BS 8414. So that was your choices, either non-combustible or large-scale test. And that stood the test of time reasonably well. We also introduced a mandatory requirement for sprinklers in all high-rise domestic buildings over 18 metres at the same time. And indeed, care homes and sheltered housing was a mandatory requirement under Standard 215. These are the sort of functional standards that particularly relate to cladding systems. So yes, we're looking at compartmentation, junction details back in 2004, separating details, separating walls, separating floors, as well as cavities, the fire spread in cavities. Obviously fire spread to neighbouring buildings and spread on the externals. So it's not just one standard you're actually covering here. It's quite a few standards, all dealing with the external wall cladding system. The interesting thing for me in this particular graphic is you can get flame extension of over 2 metres from that window, certainly up the facade on the outer side of the cladding, easily over 2 metres, possibly even up to 3 metres. Depending on the conditions. So again, your window-to-window alignment issue comes into force there. Again, that's a post-flashover fire we're talking about. Interestingly enough, obviously, we all know about the chimney effect and the fact that you can get almost about 10 times the flame height inside the cavity than you'd actually see on the outside of the building, if there is no cavity barriers installed in that particular cavity at the junction details. So the cavity barriers are really there to try and starve the fire, if you like, of oxygen, and also to limit its fire and smoke spread, really. (2013), moving on to the 3rd edition. So this is when we introduced the steel frame, the structural steel frame systems, and that was published in 2005. But this it was first cited, if you like, in this 3rd edition. So it kind of brought it together. It supersedes the 2nd edition and this BRE digest that you see there, which set the performance criteria. So BR 135 basically brought everything together. The 3rd edition brought everything together in one place: masonry, steelwork, as well as the performance criteria. So that's just a kind of wee whistle-stop tour of the background. It takes us up to recent events. When I say recent events, we're talking about January 2016, so it's still quite a few years ago now, but the Parliament Committee of Education and Skills were brought to attention post. It was the Oxgangs Primary School where you can see there the amount of masonry that landed on the playground literally an hour before the children arrived at school. And you can imagine what would have happened, obviously, had it been an hour later. Basically, the wind, I think it was quite a windy day, and as you can imagine, the wind coming over the top of that roof causing this sort of negative kind of suction pressure on this particular facade, and it pulled out that quite an extensive amount of masonry, and you can see it's quite a modern construction. Professor Cole looked into this, done a report, Professor John Cole, and he found that there was quite a lot of issues wrong with the construction, the procurement, etc. But from a technical point of view, no head restraints in the masonry, also missing wall ties. Some of the wall ties that were there were not embedded properly into the outer leaf. And again, that was all to do with the sequence of the construction, etc. So the embedment of the wall ties was a major contributing factor as well. So basically, weaknesses in the construction itself, which caused that. Subsequent to this, there was an inquiry, and it led to 17 school closures. So it became very political, and there was quite extensive work done on checking out schools throughout Scotland. And there's quite a few other schools actually closed as well as a result of this. But that was back in January 2016. And then, of course, moving on to Grenfell, we don't read reminded about what happened at Grenfell, but rapid fire spread on the outside of the external walls, and the phase 1 report clearly stated that it was ACM-PE that was the major contributory factor. So ACM with an unmodified polyethylene core, basically in the core, was the major contributory factor. Yes, there was a bit of wind on the night, but it was this panel that was the main cause of the problem. As a result of those kind of two major incidents, the Ministerial Working Group on Building Fire Safety was immediately formed, and there was subsequent reviews carried out, which I'll touch on just shortly in the fire safety world. But the compliance and enforcement, that work's still ongoing at the moment, looking at compliance plan manager roles, increasing penalties, and up to £50,000 in 2-year custodial sentence, etc. But also identifying key elements that need construction as part, that need inspection as part of this compliance plan approach. So really trying to tighten up on the whole compliance agenda. It's probably worth saying, Stuart, that Dame Judith Hackett's report of down in England, the BCR, the Building Safety Regulator, took the view that Scotland had quite a lot of useful things that they could learn from down south, i.e. obtaining warrants before you start on site. She was quite keen to learn from the Scottish model to a certain extent, that all 32 local authorities were independent. There was no private approved inspector. So she was really kind of putting quite for a regime change down south in terms of this building safety regulator, and we all know that the amount of work that's been going on in that area since. But we certainly were looking at how to improve compliance and strengthen the system in Scotland rather than wholesale change. So there's been quite a lot of work done with the Scottish Futures Board, etc., on at least seven work streams on the compliance and enforcement agenda as well. So that work is ongoing, but I'll touch on some of it a little bit later. As everyone knows, the fire alarm tolerable standard came under the Ministerial Working Group as well. It was put back a year. So I think it was February 2021, 22 came in? February 22, I think it was, it came in. And it's basically smoke alarms in living rooms, smoke alarms in hallways, heat alarm in kitchen, all interlinked, and all either anti-tamper proof or mains operated with battery backup. the sort of minimum standard, as we're all aware now. So that's been in force for quite a few years now. The fire safety regime review I'll come on in a moment, and it's worth also saying that when ministers asked the question of us officials, how many high-rise buildings do we have in Scotland? Oh, we don't know. How many have got sprinklers? We don't know. How many of them have got this ACMPE on it? This stuff that was on Grenfell, we don't know. So there had to be a bit of a stock take, shall we say, and the local authorities and building standards in Scotland really helped us out quite significantly with this amount of data gathering and research that was required behind the scenes. So that was published, and there was a second version published as well, but it's not been taken forward now because it's now getting caught up with this new Safer Buildings Register, if you like, under the cladding remediation bill. So that's something just to keep an eye on, that work's still ongoing, but it's coming in. It will come in under the cladding remediation work and the single building assessment stuff. We also introduced the Scottish advice note on it, determining the fire risk posed by external wall systems of multi-storey residential buildings. So that's wider than just domestic fire. It includes hotels, hospitals, etc., and residential care buildings, for example. So there was a need definitely identified that there was a lack of guidance in this area for existing stock and how they should assess it. So that was the first edition, was introduced in the August of 2019-20, I think it was, and then second edition December 22, I think, from memory, serves me right, which took account of some of the building, the single building assessment work as well. So there's been 2 editions of that advice note published. I've mentioned the single building assessment. So that's a new regime that's coming in through the cladding remediation bill, and it makes buildings within scope basically 11 metres and above. So rather than the high rise, it is a lower height threshold. Domestic buildings more than 11 metres, and it's looking to, the Scottish Government is going to be is funding obviously these single building assessments, which includes a fire risk assessment of the common areas and indeed an external wall appraisal. I have to say that the emphasis in the cladding bill is on the external wall appraisal and the fire risks posed in the building that could exacerbate a fire in relation to the cladding system. So that's just a subtle link there between the cladding and the fire risk assessment is worth noting.
Colin, there's one question come in the chats with regards to PASS 9980-2020.
Yes.
And the outcome on EWS1 ratings, particularly the B1. I don't know if you want to cover that as we're going through.
Very briefly, yes. So we recognise PASS 9980 obviously in the Scottish advice note. Single building assessment specification that's currently been formulated by Jules Group behind the scenes is due to be published, I think, around about May this year, and it will very much focus on PASS 9980 as the methodology for assessing the life risk. So the ESW1 is a slightly different problem because obviously it's dealing with property valuation and potentially widening the scope to property protection, dare I say it. So you could argue the ESW1 methodology is slightly more onerous. That said, I think the RICS have now been put under pressure by the UK government, and they are accepting PASS 9980 type assessments. And so eventually the ESW1s will fall ultimately and get replaced by PASS 9980, if you like. But bearing in mind that everything under the single building assessment is only those buildings that actually apply for the funding and that will then appear on the register, if you follow what I'm saying. So there will be some ongoing discussions to what happens with all other buildings that are not through the single building assessment, what happens with buildings that are maybe completely non-combustible, etc., etc. So that's, I don't know the outcome of what's going to happen there with that register, but it's certainly, the intention is that once buildings have been recorded and registered and funded for single building assessments and potentially remediated, they might not need remediation, but let's assume they do, and they're remediated, inspected, and properly certified and signed off, they'll then appear on this, if you like, safer building register for the cladding system. So I don't know enough about the ESW1 process to speak with any authority, but I know it's causing a lot of angst, shall we say, in Scotland and indeed in the UK. Just moving on to the fire safety regime review. So the focus was very much on high-rise domestic buildings greater than 18 metres and specialist housing. The review actually concluded, the overall review concluded that while fire safety in such premises in Scotland was good, there were improvements that could be made. So it was considered at that time that there was no need to introduce a mandatory requirement for fire risk assessments in common areas of blocks of flats, but it would be kept under review. The review group themselves had made 6 key recommendations to strengthen fire safety. There was specific fire safety guidance aimed at residents of high-rise domestic buildings. There was the introduction of Scottish guidance concerning fire safety in purpose-built blocks of flats. There was introduction of Scottish guidance concerning fire risk assessments. There was a recommendation for a consistent approach to the position regarding the storage, removal, enforcement and prohibition of combustible materials in common areas to be devised and agreed by all relevant stakeholders, a fire safety campaign relative to the common areas, and the introduction of Scottish guidance concerning fire safety in specialist housing, which obviously applies to many types of housing, not only high-rise domestic buildings, so your sheltered and very sheltered housing, that type of thing. As regards the fire risk assessment in common areas and blocks of flats, the practical fire safety guidance for high-rise domestic buildings was first published in December 2019, and it basically followed the LGA, the Local Government Association guidance that was down south for purpose-built blocks of flats. The guide was updated in March 2021 to include a template for assessing fire risk, and it also cross-referred to the specialist housing guidance that was ultimately published in January 2020. As regards the competency of fire risk assessors, the Scottish Government are working behind the scenes with all 4 nations in the UK to consider how best to move the quality of fire risk assessments forward, and indeed deal with the issue of the competency of fire risk assessors as one aspect that they're looking at. So probably looking at making a mandatory requirement for fire risk assessors to be competent, and then obviously then the problem then is, and then specify what that is, and whether there are going to be lines in the sand of certain exemptions, I do not know. It's not, that work is still ongoing. So that's competency fire risk assessors. As far as the storage and removal of combustibles in common areas, basically a framework was introduced into the practical guide for high-rise domestic buildings, and that was to assist those responsible with such premises to manage the combustibles left in the common areas. Largely achieved, I have to say, through partnership working with the SFRS, housing associations, and indeed factors if in the case of private blocks. The government also introduced a fire safety campaign toolkit developed to improve the fire safety in common areas and high-rise domestic buildings. And the toolkit includes things like leaflets and posters that can be printed and distributed and displayed in the premises. As regards the Grenfell Phase 1 report, I should say that that was published in October 2019. There was about 46 recommendations out of Phase 1. Phase 2 we're expecting in the summer this year. Most of the recommendations in phase 1 fell to the fire and rescue service and other emergency services. There was other recommendations directed at those who own or responsible for the relevant buildings, high-rise, domestic, if you like, and one recommendation was directed at the Scottish Government. The Scottish Government actually issued a response, and it was published in October 2020, about set out all the steps, what we were doing to consider each of those 46 recommendations. So I would expect exactly the same for phase 2 to happen as well, that the government will provide an overall response on behalf of the various parties on the recommendations. Excuse me, I'll be drinking a minute.
Well, and I can ask you a question, give you a chance to get a wee drink.
Yes, no problem.
Question's been asked by Dan. Fire risk assessments are not a legal requirement in Scotland. Is that the case?
Yes, that is correct. They're not relevant premises. I suppose common areas are relevant premises for the purposes of maintenance of firefighting facilities, but that's as far as it goes. So the Fire Safety Scotland regulations really just talk about maintenance of firefighting equipment, AOVs, automatic opening ventilators, alarms, windows, etc., risers, all that kind of stuff. Could argue the doors, stairs kit. Basically, all the firefighting kit that goes into these buildings is covered by the legislation, but not the actual fire risk assessment itself. And obviously, the single building assessment does make that, if you like, a legal requirement, but that bill is still going through the parliamentary process at the moment under the cladding remediation bill, if you follow what I'm saying. So in effect, where there's a single building assessment, it will be mandated, if you like, by the cladding remediation bill, but that's only really trying to tie in where it is in connection with the cladding system. So it does raise a little question there about the future of fire risk assessments in common areas. Should it be made a mandatory requirement for all multi-storey blocks of flats or not? So all that is currently up for grabs and under review, to be honest with you. So it's a matter of having to watch the space, I'm afraid, in terms of that aspect.
Ongoing is basically what we're saying.
Yeah, it's. But the answer to the question, there's not a legal requirement to carry out at the moment. No, fire risk assessment. So there's no enforcement. There's nothing. No, not at the moment. Anyway, moving quickly on to the grades of ACM. And apologies if people have seen all this before, but I just think it's sometimes worthwhile to re-emphasise that there are 3 grades of ACM. So, and when I first seen this aluminium composite material, I'll be honest with you, I didn't fully appreciate it was that thin. I thought it could have been like a sandwich panel, for example. So that just shows you how naive and silly I was. But so ACMP is very thin material, obviously, not more than 7 to 10 mil thick. And they've got 3 core materials: the unmodified polyethylene, which has got a very high calorific value, in excess of like 46 sort of megajoules per kilogram. Your FR grade is somewhere between sort of 4-ish, maybe 5-ish, and up to something like 20. I think it's up to about 20. And then your A2 grade is less than 4 megajoules, or up to 4 megajoules per kilogram. So you can get ACM with an A2 rating, limited combustibility, i.e. does not contribute to fire growth and fire spread, and fully compliant, if you like, with building regulations. So it is available and it is on the market. So the tests, there were 7 government tests just post Grenfell carried out on the 8414 test rig, part 1 test rig. So that's the masonry substrate. And you can see there the just typical arrangement. It doesn't show the cavity barriers or the fire barriers in place, but it shows you the typical arrangement of the type of rain screen cladding, then the rails, and then the insulation obviously exposed in the cavity behind it. Three types of insulation were tested, predominantly stone wool insulation, which was your A2, your PIR foam insulation, and the seventh test was phenolic foam insulation, which I'll come on to now. So looking at the test itself, large test rig up to about 8 meters high, if some of you maybe haven't seen it before. And it's quite a significant fire source. So if I was to stand next to that crib on the left-hand side, my head would come up to just about the height of the chamber. So it's a significant fire source. You could argue it's still quite a small fire source, but I would say between 3 and 3.5 megawatts is quite a significant fire source. You're talking about 4,500 joules of energy over the period of about half an hour or whatever. So basically, crib gets ignited. The test starts. You can see the timer on the wall there. The test starts when the first row of thermocouples reaches 200 degrees C, and then that's when your 15-minute clock starts in effect. But it is a significant test. Post flashover, remember, that's what it's trying to simulate, coming out of a window or a door opening. So that just shows you the sort of level of the thermocouples at level 1 and level 2. There's 3 different thermocouples at each level. So one thermocouple sticking through the outer face, one in the cavity, one actually embedded in insulation material. So there's three thermocouples at each level. The green walls, the green floors there you can see are just indicative of the separating floors. So I go back to my original slide there about the 3 flats. So the intention is by the time that the first row hits 200 degrees C, that's the clock starts at 15 minutes. That's usually a couple of minutes after ignition of the crib, to be honest with you. And then if the second row of thermocouples reaches more than 600 degrees C on any of those 3 thermocouples, it is deemed a failure. Also, if the flames go off the top of the test rig, is also a failure. And if it's a part 2 test, which is the steel frame, if the flame goes through the back of the actual cladding system, through the back of the test rig, that's also a failure for the part 2 test, but obviously not for the masonry test. So this is the results of the UK government tests. Test 1, which was the same material that was on Grenfell. So that was your PIR, if you like, and the unmodified ACMPE. It failed literally 6 minutes and 35 seconds after the start time. So add on a couple of minutes for the start time. So you're talking about from ignition, about 8.5 minutes from ignition of that crib. It's a little bit counterintuitive because test 6 on the right there is a pass, and that was your A2. That's your A2 ACM and the A2 stone wool. Looks like more fire damage, etc., but that was actually a pass. And the reason that obviously test 1 failed so significantly and so quickly and at such a short time, I should have actually pointed out, and it's remiss of me, Stuart, is that the crib gets extinguished after 30 minutes, and then it all sits for a further period of a further 30 minutes to see if there's secondary ignition. So basically, you're talking about an hour's test, and this was a failure at 6 minutes 35 seconds into in effect a 60-minute test. So it just went straight off the top of the test rig very, very quickly, bypassing all the cavity barriers and everything. So that's the kind of results. Some of you have probably seen this before, but it's just worth kind of reminding ourselves about some of these. So the interesting one, obviously at number 2, stone wool. So that goes back to the point I'm making, that it's really the cladding itself which is the major contributory factor here to the vertical spread. So it failed even in slightly less time than the PIR at 5 minutes and 14 seconds. Still a catastrophic failure, don't get me wrong. And again, that was because the flames were emanating above at least 2 meters above the top of the test rig. So your polyethylenes failed miserably. The FRs with polyisolate failed. Wasn't too bad, but it failed at 23 minutes and 22 seconds. And then you can see your passes there. The fire retardant stone wool. You also had a pass with the PIR in the cavity with the A2 outer cladding, and obviously the test 6 there that I showed you earlier was a pass with A2 and stone wool. So basically A2 and A2. The 7th test was phenolic foam. That was failed at 26 minutes and 19 seconds, again over the top of the test rig. So it was close to a pass. And just to highlight, Stuart, that a well-known manufacturer has now published all their 8414 tests online, and they've got the phenolic foam because of the arrangement that they put, so the cladding and the whole system test and the fire barriers. So they've now got passes for phenolic foam in the exact same test. So it just goes to show that the importance of the fire barriers, the cavities, any changes in slight detailing can make a difference to the actual, whether it passes or fails the actual test. So it's just worth kind of pointing that out. That you're
so what we're really thinking about is that it means you have to look at the full system rather than just the individual elements, because they can.
Yes, so you basically want to make sure that what's been tested is actually being constructed on the site. BS 9414 does allow you a little bit of wriggle room. It's quite strict, to be honest with BS 9414, but it does allow you to interpolate between the two sets of results. So if, for example, you've got X number of products and you're testing the whole range of the products from the best performing to the worst, you can interpolate and extrapolate, if you like, in between those two sets of results without having to repeat the test. So BS 9414 allows you to do that kind of what we call extended field of application. So it doesn't have to actually mirror every single test and what's built. You are allowed a little bit of latitude, but you have to be careful when you're looking at BS 9414. So the people that are doing all this kind of work should really be reasonably competent and understand the little nuances with large-scale fire testing that may cause a sort of pass fail or be detrimental, etc., etc. So
9414, Colin, it's just the reincarnation of 8414, is it not?
9414 is just extended field of application. Sorry, it's just a set of rules that the British Standards Committees came up with to allow you to say, can you extend the cavity size? Can you put in slightly different fixings at certain centres? Type of breather paper, the thickness of the insulation. They actually go through the whole test, materials that's in the system test, quite forensically. They're quite onerous to a certain extent, the rules in there, but we are where we are. We're in this post-Grenfell world where desktop assessments were getting not very good press at the Grenfell inquiry, and as a result, there was a whole tightening up in that space, you know. So we are where we are. So sorry, quickly moving on to HPL and stone wool. Predominantly, this test came in at the back of the Cube fire in Bolton, which most people might remember, and there was some concerns about HPL. Basically, there's different grades of HPL. Don't get me wrong; they're all timber kind of based, if you like. So they've got about 20-ish megajoules per kilogram sort of calorific value, if you were to think about it in those kind of terms. So it's kind of middle of the road type stuff in terms of energy release, etc. So this particular test passed the BR135 performance criteria. But as you can see, there's quite a lot of significant damage, and it's worth kind of pointing out that there's currently no failure criteria for burning droplets. For example, with PIR, you'll get quite a lot of burning droplets or falling debris. in this particular case, there'd be quite a bit of falling debris. And Australia does have failure criteria for falling debris and a method of measuring that. But we're just kind of watching the space at the moment because UK government's kind of quite a lot of extensive research in this area, as well as SEN, the standardisation body for Europe. So they're looking at all of this in a bit more detail. Ultimately, SEN will produce a large-scale harmonised European fire test. The news that I've got at the moment is it will be based on the 8414 type scenario, because they do consider it to be quite robust, but they may well have a slight variation for lower test rigs and etc. But I genuinely don't know. That's going to be argued out in the European technical world, I'm afraid. So that's still under development at the moment, that harmonised European large-scale test. So moving quickly on to about fire spreading beyond the dwelling of origin, I just need to quickly check my time. Yeah, okay. So the Curley Street fire was an interesting one. I just thought it'd be worth showing you this one. So this really kind of shows you an incident where a lady actually left her flat and went to visit a neighbour, and when she came back to her flat, she found smoke, obviously, and she was quite concerned about I think it was her cats at the time in the flat. So she actually wedged open the door with a chair or a slight table or whatever, just at the entrance hall to the flat, and just to allow obviously the pet to escape. And in doing that, obviously, it created this through flow of air. So a significant fire. When the fire service arrived, they couldn't get anywhere near the fire floor because it was described as like a horizontal blowtorch in the protected lobby outside the flat. But you can actually see on the right-hand side there that the compartmentation actually worked quite very well, and the vertical spread worked very well. So compartmentation and vertical spread can work in these kinds of occasions. Very significant fire, I have to say. Complete, obviously, gut out and post flashover. And as I say, the firefighter didn't really get anywhere near it until it started to die out. So looking very quickly about the stay put strategy. So when it does go wrong, when the fire strategy goes wrong and it spreads beyond the dwelling of origin into the common area, either vertically or horizontally, if you like, on the fire floor, that is a picture of the door in the adjacent flats. You can see it's heavily charred. You can see the amount of smoke damage. And there was, I think, 60-minute doors actually in this high-rise block of flats that had be fairly recently been refurbished. So when you look at the inside of the door, it just gives you a striking picture, I suppose, of how good fire doors actually work when they're installed correctly. So there'll be intumescent strips behind the hinges, there'll be intumescent strips in the intumescent letterbox, etc., etc. So in effect, people are safe. It's a safe refuge, if you like, within your own flat. The message from the fire service is, if it's not until your own fire alarm goes off should you actually have to evacuate the building. In this particular case, even if there was a bit of smoke leakage into the adjoining flats, there was no way that anybody could have been able to get out into that common area. So they would have had to stay put behind the door, open up a window, and wait for the fire and rescue service to actually intervene and rescue them. So the stay put strategy in Scotland and in the UK is still the go-to policy. Apart from, obviously, I'm saying the dwelling of fire origin, and it's still defendable. So we're not in the realms of simultaneous evacuations or anything like that at the moment at all in the UK. So quickly moving on to the changes, I'll just rattle through these. Most people will be familiar with them. October 2019, March 21 and June 22. So in 2019, we lowered the height from 18 metres down to 11 metres for non-combustibility of or a large-scale test in effect back in 2019. So Euroclass A1 non-combustible or limited combustibility, or as I say, the large-scale test. Now we also applied that same criteria to hospitals, entertainment buildings, resi care, regardless of their height. But again, as an alternative, you could do an 8 for 1 for 135. So that was the first review. At the same time, we also caught the specified attachments like your balconies, solar shading, etc. That was all caught at the time. A1, A2 when you're over 11 meters. The 11 meters was reasonably arbitrary, but we do particularly. We've written guidance in the technical handbook specifically saying it's based on a ground-mounted water jet where there's sufficient pressure and flow in the mains. And it is a reasonable assumption that you can get water up to, like, say, 4 stories. Yes, it'll maybe not get in behind the cladding, but at least if you've got a building that's lower than 11 metres, it's more accessible for the fire service to get in and open it up and get water jets in, etc., etc. So there's basically no control for lower than 11 metres in Scotland at the moment, unless you're less than a metre to the boundary type thing. And it's going to be interesting to see what happens with low-rise blocks of flats, I suppose, that are below 11 metres, that whether they meet their ESW1 ratings, etc. I'll be interested to know that, because the building regs would still allow you to build a building right now less than 11 metres, timber frame, timber cladding, timber balconies, etc., etc. I don't think people would in this post-Grenfell era, but that's our guidance really only ratchets up over 11 metres. We also introduced 2 escape stairs back in October 2019. There was no evidence base to support 2 stairs, I have to say, but it was a ministerial decision that was made at the time, and it was considered that it would provide a bit more robustness in the unlikely event of a fire spreading beyond the floor of origin and there having to be multiple stories being evacuated. So it's almost like a doomsday scenario where there's so many things have gone wrong that the fire service may well want to evacuate the building quickly and use one of the stairs as firefighting and one for escape purposes. I still haven't seen any operational guidance from the SFRS on how they're going to manage that, I must admit, yet. But which brings me on to this point, which is the BS 8629 standard. Now, this is not a communal fire alarm system. This is purely for the fire service use. So if they arrive and there's a need to throw the toggle switches, the toggle switches should be horizontally aligned as opposed to vertically. But anyway, if there's a need to evacuate the fire floor or the floor immediately above or 2 floors above, then they can throw the switches. Yes, the fire service will still knock on doors and they will still do that, but this is just an extra tool that they can use to get people to move a bit more quickly if it all goes badly and the fire is spreading quite significantly and out of control. But in theory, that shouldn't happen. Now, both the escape stair and the evacuation alert system only applies to high-rise domestic buildings over 18 metres. So the cladding trigger height is like 11 metres. These other things are 18 metres. As is the story identification signs, 18 metres. I think in Grenfell there was a bit of confusion as to what floors, etc. So we did pick up on that in the Grenfell Phase 1 report, as well as I think the alert system as well. But the main thing was that every stairwell, every firefighting lobby should have the floor number on it. And if there's more than one direction of travel, you need to put in the dwelling indicator signs below that, below the story identification signs. And you can do them with photoluminescent materials. So quickly moving on to suppression systems. There was a private members building through the Scottish Parliament at the time, and so this was delayed slightly from the original review, and we did have to pick up on the new social housing as a result of that. private members bill, which is fine. I don't have a huge problem with that. Our research in October 2019 specifically says people that are in deprived areas and say there's alcohol or drug misuse, etc., are particularly vulnerable to fire and fire fatalities and injuries, etc. So I'm not suggesting for a moment that everybody in social housing has got an alcohol or a drinking problem, but when you look at the social deprivation indexes and the hotspots, etc., you will find quite a significant number of fires and fatalities and injuries in those hotspots. So that's fine. So all new social housing and dwellings, that'll catch up your low cost housing as well. All new flats and maisonettes, quite controversial. I'll touch on that in a little bit, just in a few minutes, sorry. And shared multi-occupancy residential, so that's student residences, and basically where there's 7 or more within that particular residence, sharing things like cooking facilities, sanitary facilities. It's quite a tight definition, but we did want to catch all student residences. So even if you've got up to 6 people, you could say, well, okay, you could argue that's a domestic flat because up to 6 people, residents can live together, blah, blah, blah. But basically all flats are pretty much caught now. And since the actual, it came into force on the 1st of March, 2021, we have had quite a steady increase in the amount of relaxations coming in to the Scottish ministers, because this is a mandatory prescriptive regulation in effect. So there are challenges around extensions and conversions, but so we are, yeah, I'll touch on that in a moment. So I'll just quickly rattle through the rest of these slides since we're running drastically out of time. I wanted to leave a few minutes for if people can run over, Stuart, I don't know, but I'll not be offended if they leave, but I'm more than happy to take more questions. But
I think even if we even take the questions in the chat and then maybe get back onto them.
Yeah, absolutely. Yeah. Or if there's any new ones. So Regulation 8 was amended. So this was another review. Because England, Wales, and Northern Ireland were looking to introduce this ban. We didn't initially support it, but again, it was quite a political decision, this one, that Scotland would be a bit of an outlier, and some people who could argue it was the right thing to do. Other people like me would argue, well, you can have an A1, A2 system and it could still fail the BR135 performance criteria because there's no barriers in at floor levels, for example, depending on the arrangement of the cladding system. So anyway, we are where we are. So we've got relevant buildings over 11 metres, which you can see the definition there. Can only use A1, A2 materials. So that's non-combustible or limited combustibility materials. And there's no option to use the large-scale test now. And that's from the 1st of June 2022. The buildings covered, so this is the buildings over 11 metres, dwellings, hospitals, resi care, assembly, entertainment, sheltered housing and multi-occupied residential buildings. We explained what we mean by external wall systems in clause 271, sorry, and it basically covers all cladding systems that you can think of. So it's quite a big, if you like, bit of guidance or definition, if you want to call it that. But that's where we describe what an external wall system is, and we're talking about the outer cladding, and if there is insulation immediately behind it, that's included. Or if it's a cavity and then insulation, that's included, but it's not the frame. It's not the frame. Down in England, they use the whole of the external wall, and past 9980, as we know, it deals with the whole of the external wall as well when they're doing their assessment. So you'll get marked down if you've got timber frame as a risk factor, for example, and when your pass assessment, just because there's a bit of combustible material in the actual frame. But our focus was very much on the external wall cladding system. So we also introduced, back to the ACMPE stuff, we introduced a ban right across the board, including for internal linings in a building of any height. So we basically just want to get rid of this material as quickly as possible, get it off the market. And I think that's happened largely. So we've got quite a tight definition as to highly combustible metal composite material is, but paraphrasing, it's no more than 10 mil thick, 2 metal layers, and its combustible core has a calorific value of greater than 35 megajoules. The reason we picked 35 was because it was established category 3, part of the screening test that was used down in England, so it was already established. So rather than come up with another number, we just used the same number. And bearing in mind, ACMPE comes in at about 46 megajoules per kilogram, so it's a bit lower than that as well. So it might catch some of the FR grades, possibly. Depends on the composition of the material, to be honest with you. So we also amended Schedule 3 at the time of the building regs. So what we didn't want was like the cladding ACMPE to be taken off, and then you could replace it on a like-for-like basis. So we had to kind of close that loophole. And so we introduced, obviously, the building warrant requirement, if you like, for replacement cladding systems, except for minor repairs. So when I mean minor repairs, I'm talking about storm damage or a vehicle impact, but there's a bit of guidance in the technical handbooks which talks about, you know, where it's got to the stage where it's no longer fit for its intended purpose. But it is intended to be minor repairs, not wholesale replacement of the cladding system. So if you've got a single building assessment which suggests the whole lot should come off and replaced, then that would need a warrant. That would now need a warrant, and it would need to comply with current standards, which is your A1, A2. And obviously no option to use, I'm assuming if it's more than 11 metres. So you can no longer replace the entire cladding system on a like-for-like basis. At the same time, we also just tweaked the wording of the mandatory standard. This was really to mirror approved document B down in England, and the words in yellow is what was changed. So the guidance, if you like, now more or less fits with what the functional standard says. So we're looking for limiting the spread of fire on external wall systems, having regards to the height, use, and position of the building. So I just want to see how many slides I've got left, just a couple. So the work that we're currently doing at the moment, and is a result of the Cameron House fatal accident inquiry, which itself was it was in the January. It was in the January couple of years ago, maybe in the January, a couple of years ago. The determination, and as a result of that, there was a short life working group put together, industry, government, and the report was published in October 2023, and it made certain short-term recommendations as well as slightly longer-term recommendations. So I've picked up on the longer-term recommendations of looking at recommendations 4 and 5 of the Cameron House FAI. Recommendation 4 is basically saying that we should consider mandating a requirement for automatic fire suppression systems where traditional buildings are being converted to hotels, or should I say historic buildings are being converted to hotels. That's what the determination basically says. We should be looking at mandating that. So we're doing some research behind the scenes on that as we speak. The other recommendation was in relation to the guidance, I suppose, for not only new build, but also for existing buildings to deal with the issue of fire spread and hidden cavities and voids, and to revisit that guidance and tighten up on it if required. So again, that's part of the work that's ongoing with our expert review group that's currently been established. You can get actually minutes of meetings and things like that to all of this work, and that report is all published on the Ministerial Working Group website. And I think there's a link on the very last slide as well that people can see and keep up to date, if you like, with what's going on through that link in my very last slide. I've mentioned the competency of fire risk assessors before. Because of time, I'll not go into that in any more detail, but as one of my colleagues is looking into this, but I think I've covered it sufficient at the moment just to say it's a work in progress. It's going to be a joined up Four Nations approach. Looking as if it's going to be mandatory in terms of competency. The question that was posed earlier on in the chat, whether it's going to be a mandatory requirement for a fire risk assessment in common areas, that's constantly under review. That is being looked at. It's being obviously scrutinised by the various parliamentary committees. They'll be making recommendations, as well as the cladding bill itself deals with the common areas to a certain extent, as well as part of the single building assessment process. As I said before, the phase 2 report is coming out in the summer, hopefully, fingers crossed, and we'll be ready to obviously look at that and you know, make recommendations and carry out work appropriate on the phase 2 recommendations. So there'll be a lot of work going ahead in that space as well. The compliance plan and compliance manager roles that are going on at the moment, suffice to say, suppose the headline is that there's an early adopter scheme being just recently been launched, and I can provide a link in the group chat later so that people can go back to and click on the link. It's basically inviting contractors, developers, before the legislation's changed and comes into force, to participate in this scheme and actually to provide a bit of feedback and a bit of learning to the whole compliance process. As you know, the emphasis is now changing very much on construction and identification key elements to be inspected and signed off, and how do you go about proving compliance. So it's almost a tightening up of the existing compliance notification plan that we currently have in place. So it is only going to apply to high risk buildings. And again, the link that I'll post later, I'll identify what those high risk buildings are, but basically domestic over 11 metres, hospitals, assembly buildings, residential care, all that kind of profile. Penalties, as I mentioned before, that work is ongoing, looking at increasing to £50,000 and 2 years or 2 years custodial sentence. So quite a bit of tightening up in the whole compliance arena, which is a whole presentation in itself, Stuart, to be honest with you.
Yeah, I think we're looking at them, and there's certainly a lot of future presentations coming up.
Yeah. So in terms of I mentioned this work that's going on at the moment. So we're working with lawyers and labs behind the scenes at the moment to introduce a direction to local authorities to allow them to carry out, if you like, local risk-based decisions on low-risk conversions to flats, maisonettes and social housing, and also to extensions to those buildings as well. So we've done some research. There's a cost-benefit analysis been done, and that's all been published. So there is a good starting point for local authorities to refer to that guidance. But we're working on that direction behind the scenes at the moment. That's a short-term measure. Ultimately, the intention is that Standard 215 will be amended yet again to actually, and the direction will fall when we actually amend Standard 215. The current plan is to have that in force January 2026, but that's obviously subject to anything else that comes in from left field. We've got a detailed programme at the moment, and it's there's not a lot of room for slippage, to be honest with you. So we're hoping that nothing else comes in from left field. But so that's going to amend in the longer term, but in the short term there will be a direction that comes out to local authorities. As part of the expert working group's review on the Cameron House stuff, we're also looking to ask certainly the question about extending the ban of combustible cladding to hotels, boarding houses and hostels. England have already done that in December 19, I think it was, 2019, and Wales are just considering their consultation responses at the moment. So again, we're having to look at the evidence base for this, and we'll be advising ministers accordingly. And then ultimately it is a decision for Scottish ministers as to whether they want to extend that ban to hotels, boarding houses and hostels. My own point of view, it's a simultaneous evacuation type strategy. It's not the same risk profile, but it still is a sleeping risk nonetheless. And I totally get that. So whether Scottish ministers err on the side of caution, I do not know, but we're certainly doing the number crunching behind the scenes at the moment to establish if there's a case. There's also other things like the premises information plates on high-rise domestic buildings for the firefighter use, but again, probably too much to cover in this presentation, Stuart. It's just work in progress. The best place to find it is on the website under the Ministerial Working Group, Building and Fire Safety website. You can see the address there and keep up to date with minutes of meetings and the work that's ongoing, and that's probably the best place to. There's also links in there to the Building Standards Futures Board as well, so you'll be able to see all the ongoing work that's happening there, and there's cross links to the early adopter scheme as well. So a lot of information out there on the website. And that was just a very quick whistle-stop tour of where we came from and where we are. But I hope you found it reasonably informative, and especially for people that have maybe not seen or heard any of that before. But most people should be fairly familiar with it, to be honest with you.
Certainly, the comments from the chat, Colin, have been very very positive, and I think also we'll circulate the slides to everyone else that's been here.
Absolutely, no problem.
Because we're obviously going to have to do some CPD hours, and we'll certainly get them out to you as well. So as long as you've put your email address on, we'll get the stuff back out to you. But thank you, Colin. That's been very, very insightful. And
is there any last minute questions? If I know it's late and people want to get away and whatever, but I'm happy to take any.
Shall
questions.
We take two questions? Any questions from out there? Oops, I don't like that.
I'll just go and close these blinds. Just bear with me a second.
Gosh, that's the most close-up I've ever seen of myself, and I don't like that at all. But no, I think
no questions from me. Yeah, sure. No question from me. Thank you, Colin. Thank you. Very insightful presentation as well. I mean, for many that don't know who I am, but I am one of the Mohicans at Persimmon Homes, one of the top 3 developers. We do work across Scotland. I'm the Special Projects Director. And we've got quite significant number of buildings, HRBs in Scotland that we're currently dealing with cladding. So thank you for the presentation this evening, Colin. Very insightful.
No problem at all.
But no, it was a very, very good one. No other questions from the floor? Well, for an hour CPD and it's an hour and a half, well done, Mr. Hurd. As usual, very, very useful information for us all. And I can only thank you for stepping in and giving us some good CAPE CPD. It's great to see some of the faces again around from many years of involvement in the built environment, and actually good to actually see Dan's face for a change. I usually just see him in LinkedIn.
Thank you, Stuart.
But again, thanks for that, and we'll catch up soon. Might even take you for a coffee at some point.
No problem, Stuart.
Thank
you,
folks.
Many thanks.
Thank you. Bye-bye.
Thank you.
Bye-bye all.
Cheers, folks. Thank you.
Cheers, bye.